Hi, I'm Pakata12, and today we play with torus point cloud. And the idea was to spread some points on a torus surface and have them move or interact. And this can be done in several ways, and I will show you two methods. Okay, so let's go first. Let's go here. Remember my last tutorial. Okay, we don't need this. Okay, I said this system here, it's very nice for doing particles. Okay, now let me change this UV with something from this torus point cloud. Okay, so I have here a point cloud, and yeah, let me match the resolutions. Okay, so here is 9020 goes for the columns and 1080 for the rows. Okay, and what happened if we change this? Okay, now let me see this texture. Okay, so all the particles now are moving on a torus surface, and you see this discontinuity here. It's because we can set here in this place, instead of a mirror, we take repeat, and yeah, this is how you can drive millions of particles on a torus surface. But for today, we go with a different method. Okay, so today we'll build something that allowed us to either spread some points very close to the surface or fill the entire volume. Okay, and let me show you a little drawing here. Okay, let's suppose this is the section of a torus, and we have a point P on a torus surface, and we noise that point. So we either go with a little noise, and the P becomes P prime, and with bigger noise value, the P become P second here. Okay, and then if we take the vector from this center of the torus, okay, not center 0, instead it's this center here, and we normalize those vectors. Okay, so the orange one and the yellow one. Okay, and then the points are coming closer to this center line. Okay, and you notice if the noise value is bigger, then the point actually goes way inside the volume. Okay, let's do this. So we need this torus point cloud. Okay, and for right now, let's go with 32 by 64. Okay, and yeah, let me put a null here, and also let's split the screen, not chop viewer, geometry viewer. Okay, now I can have also a torus SOP here. Okay, and if I take those values, like for the radius, we go the same. Okay, and for the rows also, and columns. Okay, now we have this torus. If we were to instance some points according with this texture, okay, let's have some little spheres. So we go for the sphere SOP, we take polygon and details 4, and let's use a transform here, as they need to be way smaller, so 1 divided by 64 maybe, like this. And now let's see geometry component. Okay, we go with instancing and we take this texture, so let's go with R, G and B. Okay, now let's use a different color, so we take a Fong and let's use it in the render, and this Fong is maybe red. Okay, now we have some points on a surface, okay, and I would like to have them much random, okay, so now they look like the grid, okay, and let's apply some noise to the point. So we go here and have noise. Okay, we connect both, we set the offset to 0, and let's put the amplitude to 0 also. Okay, now if we increase the amplitude, okay, the points, now we don't need monochrome, so okay, now look at the points, they get quite random like this, but you see they leave the surface, okay, and also they went inside also, okay. Now I would like to find the vectors from the center line, okay, and the points, and that center line, it's here inside, you see this texture, okay, this one, and we can as a reorder 5, okay, so we can go with the select here, and let's use torus point cloud in the select / reorder 5. Okay, you could also use something else here. So as the torus has those rings, you know, like slices, if you use here pixelate, okay, and you pixelate with so vertical size is 64, no 32, sorry, so we go with 32 for the vertical, and okay, now we have the same texture, okay, yeah, and by finding the vector from the center, those center points to the red ones, we need to subtract them, so we do subtract, okay, and now I would like to normalize those, okay, so I have to normalize. Let me show you again. So I have to normalize those orange and yellow vectors to the same value as this red from the center to the initial point P, okay, which is actually the radius 2. Okay, so what we can do is normalize to 1. Okay, so for this I can use normalize. Okay, what this does is only a composite with divide between the vector and its length. Okay, so now we multiply with the radius 2. Okay, so we use mod here. Okay, and let's go with this radius 2 from here in multiply. Okay, now we have all the vectors the same length as the radius 2. So we need to add them now. So we add them to the center points, and let's see them now. Okay, now all the points went to the surface. Okay, this is super nice. Okay, but actually they went closer to the surface. Okay, so some of them are inside. So if we press W, yeah, some of them are a bit inside. Okay, but this looks super nice, as it's a very nice random distribution on a surface. And what happened if we go very crazy with this noise? Now they go inside, most of them. Okay, and yeah, this is nice. I would also like to have this moving. Okay, so let's go back with the noise 165. Okay, and see it like this. I would like to see them move. Okay, and we can do this by going here and ABS time dot seconds divided by 30, maybe 32. Okay, and yeah, now they are moving, and each point it's visible as the vector. It's not so big. The noise is not so big. When the noise is going a little bit bigger, they go inside the torus, and that's why some of the spheres look smaller. Okay, and now I would also like to have this this surface being noised, as this idea came as I was working for the method for donuts. Okay, so those spheres, it's like sugar crystals or whatever above the donut. Okay, and yeah, the donut is not perfect torus. Okay, and one idea is to noise this SOP, but and come to compensate with the noise for the tops, but those noises would be completely different. Okay, one is done on CPU, the other one is done on GPU. So the only way to match this particular SOP with the noise is to translate. I mean to use the displace points for the noise from a texture. So you go with tops, chops, and SOPs. Instead, I would like to do it a little bit different. As okay, I see this torus because it's a mesh, right? But I can also see a point cloud. Okay, much denser than this. Okay, this is only 64 by 32. So let me copy this. Okay, and I want to make this. Let's go with 1024 by 2048. Okay, and let's use a null. And now I would like to see it as, and we will use point sprites, because here we have millions of points, and so even with a box, the FPS will drop. So let's make a point by having a add SOP here, add a point, and now we convert that point to particle and render as point sprites, And let's use a geometry now. Okay, and yeah, we go with instancing and we use this. And let's see now R, G, and B. So right now they are quite black, so let's use a material point sprite. Okay. Now we have this. So if we get closer, we see the points. And you can also see the spheres inside. Okay, and now it's much faster to noise this torus point cloud. Okay, so let's go here and use a noise. Okay, like this. Let's go with 0.2 scale and maybe period 2, and now we play with amplitude, and you see now it's looking more like a donut. Okay, now one way to get rid of some of those points you see through, okay, it's to go here and on a constant point scale, let's use 2.6 to 5. Okay, and you notice now our red spheres doesn't stay on a surface. Okay, and first let's put nicer material on this. So I would like to go with checker. Okay, so we can use a null here. Let's make those two pink as we use them. So here we use this material for the colors. So R, G, and B. Okay, they have to be the same resolution, and so here in the checker I need to drag those values. So columns goes for X and rows for Y. Okay, and yeah, maybe 8 here, or let's go with 32 and 16. Okay, now we can use a edge here, and if we want, let's set this mono, and then we have only the lines. Okay, and we also can make this noise moving by going ABS time dot seconds divided by 30. Okay, now you see we need to put back the red dots on a surface, and what we need is using the same noise. Okay, so we have this noise right here, like this. Now the points are taking the good place on a surface, and we can actually go here and try to bind the parameters. Okay, so let's go on the first tab, and yeah, we need to have the exact same noise. So we drag the parameters and we connect with bind. Okay, and by doing so you can either change this noise and this one will align. So okay, I'm not sure how many parameters you will play, so but those two has to be identicals. So and also maybe here in translate. Okay, I believe I did wrong here, as yeah, I forgot to take the bind. So you can also check the colors. If the colors is purple, then it's a bind. Okay. Now, yeah, this was the method that I found very nice to use, as you can either go closer to surface and still have that randomness, or you can go inside. Okay, now if you go crazy with the noise, okay, and you want to have all the points inside, there are some of them on a surface, okay, you can have here minus some distance. Okay, so if I use here minus 0.0625, okay, now yeah, now I have a little gap between the volume taken by the red spheres and the actually torus. Okay, and yeah, you can't see it with this, but yeah, look, so everything is inside, and they move nicely. Okay, so let's go back with this, and yeah, this was my tutorial. I really hope you like this, and yeah, thank you so much for your support, and see you in the next one. Bye.